Good morning, everyone. Today, for our first presentation, is Sruthi Pisipati, did I get it right?
That's right.
From Boston Scientific, and she is here to talk about building trustworthy AI.
Yes.
Thank you, Sruthi.
Thank you, yeah. Hello, everyone. I hope you enjoyed your keynote. Thank you so much for being here. I'm Sruthi Pisipati. I'm a principal data scientist at Boston Scientific, and I'm really excited to be here today to talk about this topic that I'm deeply passionate about, building trustworthy AI. Before I begin, I would like to stress one thing that I'm not representing Boston Scientific in any official capacity today, so any thoughts, experiences, examples that you'll hear from me today through this presentation, those purely come from my personal learnings and experiences. Okay, with that disclaimer, let's proceed to who am I. So I'm a software engineer turned data scientist. I bring over 11 years of experience in AI, software engineering, and ML across various domains, consulting, insurance, manufacturing, and now medical devices. My expertise is in computer vision, generative AI, classic machine learning, which also includes building forecasting solutions. And at home, I'm a chef to my two adorable daughters under 5, and my husband. I love cooking, and when I cook, I love to dance and listen to good music as well. So that's about my hobbies. Now, why this topic, right? Why do I care about trustworthy AI so much? Let me just reflect here a bit. Back when I was doing my master's, in one of the coursework, one of the tasks given by the professor to the students was go build the best machine learning model or image classification model possible so that you can be top on the leaderboard, just like how your Kaggle projects work. We all did that, build the best model with best F1 scores. In complete contrast, when I joined Boston Scientific, when I was working on an image classifier, I used efficient net architecture, CNN-based architecture, state of the art. That was fantastic, that gave us fantastic scores. I walk into a meeting, present that. Stakeholders say, why do we trust this? Why do we trust your model? The scores are fantastic, but will it really work? So that brings us to the learning that performance isn't enough. You need to earn the trust of your stakeholders. And if you're able to build a best performing model, which is trustworthy, that's only half the battle. You need to make sure that you need to deploy the model or operationalize it in a responsible fashion. So that's the motivation behind this talk. Now, for the next 20-ish minutes, I would like all of you to be my AI engineers and AI product managers who would help build, think, and go through this case study and build a solution together, okay? So this case study is quite simple. In med device companies, we have complaints coming in. So once the medical devices are launched in the market, we have complaints coming in. And then those complaints have to be carefully analyzed by quality teams within med device companies. They have to be categorized to different categories. And then after that, the documentation should be reported to the regulatory systems. This is pretty intensive, labor-intensive task. More than one person has to go through each and every complaint just to make sure we are not having any compliance risks here. And sometimes there could be high volume of complaints as well if there is a new product launch. And as I said, this is highly repetitive. More than one person will need to look at the same complaint. This might vary across teams as well, and because complaints are open to human interpretation. So you might miss some codes there. There might be some inconsistencies there. So for this case study, AI is a very good tool which can help reduce the human load and bring consistency into the picture. Say if we are not going through path A and B, and having A1, B1 path, which includes AI model with human oversight, will not only be able to reduce time-consuming tasks, that means we'll bring in efficient turnaround times, but also we'll be able to bring in consistent standardized coding mechanisms. And this activity, the complaint coding activity, is highly expertise dependent. So if you don't have experts, this can have all the risks. So with AI, we will be able to do that knowledge retention. The tribal knowledge, that we'll be able to capture with this AI tool. And last but not least, say if your med device company grows, you have more and more med devices. With AI tool, there is an option to scale with growth. So now we have the motivation of why we need AI tool for a case study like this. So, what does it need to build this tool, right? First, we need robust solution design. Your engineering foundation should be very strong. And then we would need to have guardrails like traceability, transparency, and governance. You'll understand more as we proceed through these slides next. So the combination of this robust solution design plus traceability, transparency, and governance would help us build a complete package of trustworthy AI where good design meets good oversight. Okay, so now I mentioned that in last slide I mentioned that you're all my AI product managers and AI engineers. So for us, the first task is to sit together and try to analyze what would be our engineering requirements to build a solution for this. So for engineering considerations, for our version 1, say our prototype is version 1, we would go to our product owner and seek some design inputs. The first question would be, who are our target users? Our target users are quality teams who would be going through those huge pile of complaints and then doing that labor-intensive coding task. So those are our users. They're a small group, typically in double digits. How would they access? They would typically want simple front-end interface. Time would be, this is again latency requirement. 1 or 2 minutes per complaint is maybe acceptable. Model, local LLMs for data security and speed. So these design choices shape our first prototype. Very well. Now with those engineering requirements, we go ahead and build this first prototype. We have our complaint data set, and if you're aware of Streamlit UI, how many of you are aware of Streamlit UI? Streamlit is a Python library. It helps build UI really quick. So Streamlit UI would be our simple interface, and then we would upload complaints to that interface. We'll use a local LLM based query, so that's our AI engine. It would do our code assignment. That will download output. Simple, right? Can you think of any limitations in this architecture? Yeah, that's right. So there are certain limitations to the version 1 which I presented. Accuracy limits, mistakes. Local LLMs are less accurate than GPT series or the state-of-the-art models like OpenAI's GPT series or Anthropic's Claude. They are not accurate, and how much ever you train them, they might not pick up patterns really well as compared to the GPT series. And limited context length. Complaints can be very large. If you are trying to fit those complaints into local LLMs, it doesn't work sometimes. So limited context can be a barrier for the version 1 solution. And this is a very important piece. The problem statement which I'm talking about, it's not a simple cat versus dog classifier. It's a multi-class, multi-label problem. You'll understand more in the next slides. So now let's try to understand the complex taxonomy here. Let's do a role play. Say I'm a patient. I got admitted to a hospital and I'm being administered a stent device by my physician. Now I really hope none of this would happen. So when my physician is trying to administer the stent into my heart, say the stent did not deploy well. There's a problem. So what would the physician do? He would raise a complaint with the medical device company saying that there's a problem with the stent. It did not deploy. What would the medical device company do? It would receive the complaint and it would start opening each of these categories which I'm showing on the screen, starting with AR codes, as reported codes. What did the physician report? That would go under as reported category. And then the next would be as analyzed. The medical device would be returned to the medical device company and then they would do some analysis. What was their analysis? That will be coded under AA category. And then patient code. What are the conditions, new conditions which the patient had to encounter because the stent did not deploy well? Did the patient have a heartache? Did the patient have bleeding? Did the patient have some trauma? So all of those conditions will be captured under patient codes. The next would be impact code. What was the severity of the outcome because the stent did not get deployed well? Was it a hospitalization, death? That information will be captured under impact codes. And then method code. What was the investigation? How was the investigation performed? Was it a visual inspection, functional testing? That will be captured under method code. And finally, what was the conclusion of this whole investigation? That will be captured under conclusion code. So there are like 6 different classifiers, if you will, for this particular problem statement. And adding to the complexity is for some of those categories, multiple classes are allowed, and for some of them, single are allowed. For example, conclusion code, which is root cause, can only have one item there, but for AR codes, which is device issues, can be multiple. So again, this has to be done accurately, multiple versus single. And here is the breadth of classes which can go into each of those categories. You can clearly see how complex this problem statement is. For each of these categories, there can be classes ranging all the way from double digits to thousands. So overall, it would be 30,000 plus classes, and this will increase if the medical devices are increased and if there are the patient outcomes are increased. More and more codes get added each day, and for a human who is reviewing the complaint, they have to be really precise in coding categories for a particular complaint. So this clearly cannot be done with a simple classifier. We need something called as vector search or RAG layer, if you already know about this. So what we are going to do is, we have 30,000 classes. Imagine we have 30,000 classes with this example. We'll convert this 30,000 classes, which are mostly alphanumeric, to vectors and create embeddings for them. And the thing where we got lucky is metadata filtering. So each of these classes come with metadata. For example, stent belongs to cardiology department, and catheter can come from endoscopy. So you can do that metadata filtering in the second stage, which would reduce your classes from 30,000 to 400. And after that, stage 2 vector search, that's the heart of this solution. That's called the RAG layer, retrieval augmentation layer. So there we'll be able to reduce the 400 classes to top K classes based on your complaint, using some similarity search or cosine similarity techniques. And finally, that will be given to the LLM for reasoning, and the final class will be output. If I have more time in the ending, and if you're interested, I can deep dive into the technicalities of the vector DB search. So with that, now we are building our version 2 solution. We are moving from local LLM to cloud to access state-of-the-art models like OpenAI's GPT. And we are moving the complaints dataset to Azure Blob. Again, that is cloud as well. So complaints dataset will move to Streamlit UI, where we are going to upload our complaints. Then we'll do our vector search, which I just explained in the last slide. Then we'll give prompts to our AI, which will do the code assignment. And finally, we'll download the output. And if you're interested in the technical details of what stack we can use, those are the technical details. The question remains, is version 2 solution trustworthy? Can you think of any limitations? Sorry, what's that? Yeah, computing cost, yeah. And what else? Feedback loop, that's a good point. Computing cost, feedback loop, and I already gave you answer actually in the version 1. So in the version 1, I told you that LLMs, we are using local LLMs for data and security. But now we are moving from local LLMs to cloud LLMs. What about security now? Are we compromising with our security? Med device companies cannot. So we are dealing with a lot of sensitive, customer-sensitive information, PII, PHI information. If we are not taking care of the customer complaints or customer information, preserving the customer information or redacting the customer information, then that's not good. We are not HIPAA compliant. So first and foremost task for us is to redact all the customer-related PII, PHI information. And once that's done, there is limitation number 2, API secret key storage. So if you're an AI developer or Python developer, you would know this. Most of us, what we do is when we access our APIs, we would just write those API secret keys in .env file, and that's it. But that's not a good practice. We need to move to secrets manager, which is again cloud provided facility, like AWS, GCP, or Azure would have the secrets manager. Move your keys from .env files to secrets manager, which would make your keys rotatable and add more security to your solution. So that is limitation number 2. Good. Now we move to version 3. In version 3, I have added 2 blocks, which is redaction. So we have handled our sensitive information, and then fetching API keys from secret manager, and rest everything remains the same. Question remains, is version 3 solution trustworthy? Can you think of any limitations? Hallucinations. Okay. How would you figure out that there are hallucinations, right? And you brought up a very good point. Feedback loop. Exactly. So we have addressed everything. Robust and scalable solution design. We have accessed state-of-the-art LLMs, vector DB, search. Everything is fine. But say on a fine Monday morning, you are in the quality team and you receive 3,000 complaints on that day after a new product launch. The AI could very quickly process all those complaints within, say, 4 hours. So at the end of 4 hours, you have all your complaints coded. Will you directly report those coded complaints to FDA? Will you believe what AI gave you? Not really. We need verification and validation of AI results. The feedback loop is really important. How would we do that? We need to build a verification and validation AI ecosystem. So the complaint tool, the AI complaint tool, so far whatever I was discussing, if it is called as complaint IQ, then we would need 2 other additional AI tools, verdict code AI and validate code AI. Verdict code AI, you can use that when human codes are available. Say, for example, you launched the AI tool a month ago, and humans have been coding in parallel in the last 1 month, and you just want to audit it. Who was better? Is human better or LLM better? So what you would do is you would just pick those 2, but there are, say, 10,000 plus complaints. So in such kind of cases, you can use verdict code AI, which is again an AI tool, but the role of this AI tool is different than complaint IQ. Verdict code AI is a judge here, which would analyze whose coding is better. Is it AI or is it human? So when human codes are available, you would use the verdict code AI. When human codes are not available for fresh complaints, you can use validate code AI. So this is the verification and validation ecosystem. How would this work? We are using LLM as judge framework to accomplish both the verification and validation AI tools. So for verdict code AI, the inputs would be AI predictions plus human codes. Those would go into the verdict code AI, the AI tool, and then it would spit out judgment saying who is better, LLM, human, sometimes both, sometimes neither. It would also give you confidence score, how confident it is of its judgment. And then it would give you its rationale as well. And finally, you would get a nice Excel report of its judgment, its confidence score, and we can actually talk about some metrics as well, which are necessary within this tool. If time permits, I'm going to walk you through the metrics. And for validate tool as well, the process remains similar. But here, the outcome is whether the judgment is valid or invalid or unclear. You can use more than one LLM to validate the outputs of your complaint IQ. So that's the reason you are seeing agreement or disagreement metrics. Okay, so what we need to build a trustworthy AI, we need an AI ecosystem, plus we also need a golden truth data set. Just having an AI ecosystem wouldn't be foolproof. You need to have a golden truth data set, and you need to have your stakeholders curate that data set and also periodically check it against your data. This is all the more important because nowadays we see that we have no control over OpenAI's released models. They can be quantized, they can be pruned. So suddenly they release a new version and the interpretation of the model could be different. So you need to make sure that you have that golden truth data set in place against which you keep checking often how your AI ecosystem is working. So you need to check against the 3 different AI tools here: complaint IQ, verdict code AI, and validate code AI. So if you're able to do maintain this AI ecosystem along with maintaining a golden truth data set, that's when your stakeholders will believe in your AI tool. Go with those metrics and show them. And the story doesn't end here. There are other questions which every AI team should keep asking. Fairness and bias. Are you addressing any bias in your model? How are you maintaining your prompts? Prompts will only get larger and larger. Within medical device company, there are a lot of rules. So how would you capture those rules? You cannot just afford for your prompts to get larger. And scalability issues. Can your simple UI handle thousands of complaints? Do you need to move to something like React or JS? Is Streamlit just enough? Or do you need overnight batch jobs to process those complaints? How does that look like? So these kind of things, you should keep handling it. And if you're wondering, can agentic AI help make this solution better? Definitely yes. We are already working on it. If I have another 30 minutes, I can probably go into it. So yeah, agentic AI can definitely help this solution make better. So summary key takeaways from building trustworthy AI are privacy first. Always start with your data privacy protection early, and then go with metrics. Curate those metrics. Make your stakeholders your partners. Ask them what are the metrics which they would like to see, and then think about engineering constraints early. And finally, iterate and improve. Always make sure that you have that feedback loop to make your solution trustworthy. So trustworthy AI means privacy, metrics, engineering, and iteration. Thank you so much.
All right. Well, now we have a little bit of time for questions. That was fascinating. Actually, having been in a medical device company trying to do that exact same thing,
Sure.
We didn't get nearly this far. So awesome to see this. So, questions from the audience.
That was an awesome talk.
Thank you.
I'm just curious, how do you extend to new devices? Is that implicitly supposed to, like, are you supposed to wait and have new data on those before you can start processing complaints for them?
Yeah, so for new devices, we cannot directly use this AI tool. So this AI tool, we are building this AI tool on the data which we already have available. So once the new devices come in, humans have to spend some time on it until that data is ready, and then we can extend it to AI. So AI is only used as an aid. We cannot just completely switch from human to AI here.
In the back over here. Thank you. In tracking data, are you keeping labels on, okay, this is AI generated versus this is human generated, And second, I think you might have a slide on that, how you do that, validate AI and that. I would like to understand more around the mechanism of like how those processes work.
Which slide exactly are you talking about?
You got it, the verdict AI and the validate AI, like those two pieces,
Oh,
so
yeah.
you could just get to the
are you-
intuition of how it thinks through or how the process works there. So, but first more like synthetic data, like, or maybe not synthetic, whatever's generated by the AI.
Yeah, so like I said, verdict code AI would have inputs. The two inputs are AI predictions and human code. So human coded data is already available in this case. So both of those will be passed, and this is how the output would look like. I'm not sure if you're able to see, but from verdict code AI, you would get a judgment for it. So this was the output of 5 complaints, where we had human coded labels and the labels coming from AI. So if you look at this judgment, the verdict code AI says that LLM is better in 4 cases, and both are better in one, and both are equal in one particular case. Does it answer your question?
I think we have one more up here. Do you have one?
Do you see a place where we could use agentic AI in your architecture?
Oh yeah. So is talking about the vector DB search, the yellow star. This is where agentic AI can be used. So the 400 classes which comes from stage 1 metadata filtering, those might not be accurate every time. You need to have a self-reflect loop or agentic AI loop which thinks for itself whether the 400 classes retrieval for a particular complaint is good enough or not. Maybe it's a very, very broad search. Maybe it just needs 60 classes to think through. So that stage 2 vector search is where we would need agentic AI to have that self-thinking or self-reflecting loop.
Yeah, this was just a follow-up on the question about deciding which is better, the human or the LLM coding. How would an LLM be better than a human, right? Because those are the only two options. It was the LLM is better or they're both kind of the same. How does it decide that the LLM is better than the human codes?
Yeah, so like I mentioned, this is a highly labor-intensive task. So a complaint can have history. Like I walked you through different phases of, life journey of a complaint. Complaint can have history. So humans looking at a complaint might miss some nuances. But with LLM, what we are trying to do is we are doing that knowledge retention or all the rules which the LLM needs to know, we are passing into the LLM as a prompt. So a human can miss because of fatigue or whatever it is. It's very, like I said, labor intensive. It's very difficult task for a human to go through the entire history. But for an LLM, there is no fatigue. So it would just go through the rules and try to map its understanding of the rules to the complaint and come up with a better coding coverage. So this tool will also help us to find those inconsistencies which humans can have while looking at a complaint.
I think we do have one up there. You've been very patient. Thank you.
I'd like to know where you are on kind of the trustworthy journey for this app. Because I could imagine that trustworthy is kind of like a leaky bucket of water. You have to keep patching holes.
Yeah. I guess now we have at least modified our AI tool for the 10th time. We have started the development of this tool in the last couple of months. And it's not easy because there are just a lot of rules. With respect to trustworthy AI, we are depending on the verdict code AI tool, which I was just showing few moments ago, with these kind of metrics. So humans have to go through the complaints. There is no escaping from that fact. But this tool can help prioritize to look at which complaints first. So for example, in this particular case, there are 4 complaints where LLM has performed better. So as a quality team, what I would do is I would look at those 4 complaints to see where the humans have missed. The both categories just one, so I might just skip that. So prioritization is where the trustworthy AI piece is helping with having these kind of metrics.
I think we've got one. Oh, sorry.
Hi, I'm curious how you mitigate the risk, especially in a regulatory space, of LLMs not being deterministic in their output.
Yeah, so like I said, AI is just an aid here, which would help us focus on the complaints which matter. So we are not removing human out of the loop. AI is acting as an aid, and we always have human oversight before we report it to regulatory. Think of it as a tool tip or a suggestion which comes when you're trying to code. You might read the complaint and you might immediately come up with few coding categories, but when you look at the AI help, it might suggest differently, or maybe it might give you some more codes which you might have missed. So that's where AI is bringing more help here by acting as an aid. With respect to regulatory concerns, because we always have human in the loop, and because this is not an AI standalone solution, it doesn't hurt much.
An online question, how often is the golden truth data set audited in your scenario?
So right now, because we are in the early stages of development of this tool, every 2 weeks. Every 2 weeks, we are getting a golden truth data set, which is being reviewed by our quality team. And then we are, based on their review, so they tell us where AI is wrong. So when they tell us where AI is wrong, we are taking that input and making our prompts better and making our AI model better. So every 2 weeks right now until it gets stabilized, but once we see good results, I guess it would move to once in 2 months or once in 3 months.
I was just wondering if there's any special pre-processing or data requirements that you have to do before the step you highlighted about the HIPAA redactions. And like, I was wondering if you could say more about how that's done. I'm assuming it's some kind of AI that's going in, and how do you deal with the misses there?
HIPAA compliance, right? So right now we are using Azure AI language services. There are a lot of tools which can redact for you. But even before you reach that redaction step, there is a lot of cleaning that needs to be done to your text, because complaints can be all over the place. A physician at one particular hospital might have a different language compared to a physician at another hospital. There might be special characters. So all of that needs to be cleaned before you send your complaints to the tool like Azure AI language services, or you could write one script as well to redact.
Hi, thank you for your talk. It was really interesting. My workplace is also trying to implement something really similar to this with metadata, and I was just curious as to like what kind of prompt engineering went into the LLM reasoning, and I guess how that impacted your like workflow in creating all these different versions.
Yeah, probably now was the juncture that I should give credit to my other data scientist on team. Haris Jawad, his other data scientist on the team, he has been working on prompt engineering a lot, and I can say that a lot of effort goes into the prompt, because you need to make sure that the tool doesn't hallucinate. And often if you don't tell the tool or give the tool specific instructions, it would come up with its own made up stories. And it's not acceptable for a coding, AI coding tool like this. So you need to capture all of those rules, the tribal knowledge, like I was mentioning, sit with your stakeholders or quality team who are behind those rules, understand the devices and the complaints, read through them, and include them as part of your prompts. But like I said, prompts will get larger, so you need to store them in a vector DB and use libraries like LangChain or Llama Index for better prompt maintenance strategies.
Okay, we have one more quick one, and then we have to wrap it up. So if you have more questions, let's find her afterwards. Thank you.
Yeah, thank you so much, and really amazing talks. And my question is about like situating in the context that is about like coding the device compliance. Maybe the operation team and device team and hardware teams would be interested in the result. So I'm quite curious how your team like collaborate with maybe device and hardware team to know like what they need from the code book and the results.
So is the question, how are we going to use the output of the coding categories to share with the device team for further improvements?
Yeah.
Yeah. So actually that's where this whole coding exercise helps. So the AR codes, device issues, right? Once we get those device issues, further downstream processing is done on that data to see what are the devices which are being failed multiple times, or what is the common failure type? Is it some kind of short circuit or some kind of breakage? So those patterns are picked up in further downstream processing. So once those patterns are picked up from the post-market complaints team, that would be shared with the R&D and the hardware teams.
Thank you.
Awesome. Thank you so much.
Thank you so much.